Hi, Year 11s. It's Miss Strange is here with paper 2. Here we go. All right, question 1. They used to start with our multiple choice questions, but now we just have some fairly straightforward questions here. So here is a sequence. Write down the nth term for this of the sequence. I would say if it's at the beginning of the paper, you're probably not looking at it being a quadratic sequence, but let's go ahead and check. So let's first find out what all the differences are. So from 15 to 19, we've got plus 4, and 19 to 23, we've got plus 4 again. It looks like each and every time it's going up by 4. So we're going to compare this to the 4 times table. So underneath all those numbers, I'm going to write out the 4 times table. All right, so since all of this is in the 4 times table, I know part of my answer is definitely going to be 4n. If I go ahead and subtract these, 15 take away 4 is 11. 19 take away 8 is 11, 23 take away 12 is 11, and all of these differences are going to be 11. So this is the 4 times table plus 11 more, so 4n plus 11. Question 2, triangle A is enlarged to triangle B. So we go from triangle A, it is enlarged to get to triangle B. They just want us to write down the scale factor of the enlargement as a fraction. So we want to get from A to B, and we need to leave everything as a fraction. So we're going to look at two sides that are the same, the 6 and the 4, and we're going to compare them. We're going to say the bigger shape divided by the smaller shape gives us 6 over 4. You can leave your answer just like that, or you could simplify it down to 3 over 2. Okay, they don't want you to write it as a decimal, they want you to leave it as a fraction. There we go. Question 3. The length of a table is 110 centimeters to the nearest centimeter. Complete the error interval. Well, when I read to the nearest centimeter, I always think to the nearest 1 centimeter. And for our error interval, we're looking for our upper and lower bound. So 1 divided by 2 is 0.5, and we're going to add that on and subtract that from 110. So you want 110 plus 0.5 for the upper bound, and also 110 minus 0.5 for the lower bound. So 109.5 up to, but not quite including, 110.5. There we go. That's all they're looking for in that question. For question 4, at what point does the graph y is equal to x cubed minus 2 cross the x-axis? You might be thinking, this isn't really fair. I don't know what the graph of y is equal to x cubed minus 2 looks like. And that's fine, but if they're looking for where does it cross the y-axis, that is going to happen when x is equal to 0. So we can go ahead and substitute that in. Y is equal to 0 cubed minus 2, which is 0 take away 2. 0 take away 2, which is going to give us negative 2. So this is going to cross at 0, negative 2. Okay, you can also tell, there's lots of other ways you can tell, but if you wanted to do the working out, if it crosses the y-axis, that's going to happen at x is equal to 0. Question 5. The cash price for a boiler is £2,000. Customers can pay the cash price or they can pay monthly. So the cash price is £2,000 and the pay monthly is 60 monthly payments of £40. Work out the percentage increase from the cash price when paying monthly. Well, if we want to find a percentage increase, we need to find out how much the percentage has changed divided by the original amount. And then we can times that by 100, and that will give us our percentage increase. All right, so first of all, we've got our cash price is $2,000, and then if we pay monthly, that is going to be 60 payments of £40, which is going to be £2,400. So let's go ahead and find the change, 2,400, the takeaway 2,000. So that is going to find us the change. You obviously don't have to do that. You could have just written down 400 and it would be all right. Divided by the original amount. So they said originally the price is £2,000. So divide that. And then because we've got a calculator, I'm going to write times by 100 to turn it into a percentage. So this is going to look like 400 divided by 2,000 times by 100. And you know what? I'm sure I should be able to do this without a calculator, but we're going to do it with a calculator anyways. 400 divided by 2,000. Oh yeah, it's 1/5 times by 100. That's going to give us 20%. And that's all we're looking for in that question. Nice and simple, 4 marks. Okay, percentage increase. Well, when we're looking for the percentage increase or the percentage change, it's always the change divided by the original amount times by 100 to turn into a percentage. There we go. Question 6. An exhibition was open for 240 hours and had 29,760 visitors. For two-fifths of the time the exhibition was open, there were 172 visitors per hour. For the remaining time, how many visitors per hour were there? All right, so there's two different things I would say that we need to unfold in this question. So for the first part, they said there's two-fifths of the exhibition, there was 172 visitors per hour. Well, we don't know how many hours that is. So first we're going to have to work out 2/5 times by 240, which is going to give us 96 hours. So for 96 hours, there was 172 visitors per hour. So that kind of looks like a ratio, if you will. Depends on how you want to think about this. I would say for 1 hour, there was 172 visitors, but we want to find out about 96 hours. So we got to times that by, well, the 172 by 96. So in 96 hours, there must have been 16,512 visitors. Well, we know over the entire time the exhibition was open, there was 29,760 visitors. So 29,760 minus 16,512 gives us 13,248 visitors over the remaining hours. Well, if for two-fifths of the whole time it had 172 visitors per hour, that must mean for 3/5 of the time, so 3/5 times by 240, or I could have just subtracted it off. If I'm going to be honest, I don't know why I didn't just do that. 0.6 times by 240, we get 144 hours. So in 144 hours, they had 13,284 or 48 visitors. So now we want to know the visitors per hour. So we have to do visitors divided by the number of hours. So we have 13,248 divided by 144 hours. 13,248 divided by 144 gives us 92 visitors per hour. And that's what we're looking for there. Nice question. Very different than anything I've seen before. Question 7. I feel like these questions are getting more and more popular. A lot of times people think that there's way more things to them, but a lot of times there's not. This one wants us to actually work out some codes. Most of the time it just wants to figure out how many possibilities there are. A code is a 3-digit number. So whenever I see a question like this, I think right away I'm thinking of 3 dashes like that. The first digit is a square number that's greater than 1. All right, let's organize. Well, let's just read the question first. The first digit is a square number greater than 1. So 1, 4, 9, 16 is what I'm thinking. The second digit is a cube number greater than 1. So like 2, 8. 2 is not a cube number. I don't know what I'm saying there. 8. 64, 125. The third digit is a prime number. 2, 3, 5, 7, those kinds of things. And the 3-digit number is divisible by 3. Okay, lots of things happening here. Work out the two possible codes. Okay, so we have 3 digits that we can have here. The first digit is a square number greater than 1. So 2 squared is 4. 3 squared is 9. 4 squared is 16. Now we can't actually use 16 because 16 is a 2-digit number, but this is just the first digit. So the first number can only be 4 or 9. The second digit is a cube number that is greater than 1. So 2 cubed is going to give us 8. 3 cubed is going to give us 27, but again, we're going to end up with that same issue. 27 is a 2-digit number, and we only need this to be a 1-digit number, so that's not going to work. And then the third digit is a prime number, so 2, 3, 5, 7. The next number after that would be 11, but again, that follows our same issue as before of it's a 2-digit number. The three-digit number is also divisible by 3. Okay, so let's write out some possibilities. So we've got 4, 8, and 2, 4, 8, and 3, 4, 8, and 5, and 4, 8, and 7. Okay, so those are some possibilities. We also have the first number, instead of being 4, could be 9. So you could have 982, 983, 985, and 987. A really cool trick if something is divisible by 3. So I'm just going to randomly tell you a number in the 3 times table. Let's go with 36. So 36 is definitely in the 3 times table, but 3 plus 6 is equal to 9, and 9 is divisible by 3, so we can always check. That means that 36 definitely is divisible by 3. I can show you that with a bigger number, like 102. That is divisible by 3 because you have 1 plus 0 plus 2 gives you 3, and 3 is definitely divisible by 3. So you can just check by adding up the digits and see if they are a number in the 3 times table. So 4 plus 8 is 12, and then 2 gives us 14, 12, 15, 17, and 19. So from here, I can see that these numbers right here, 15, is going to be in the 3 times table. So one of our answers is going to be 483. And then let's check the other numbers. 9 plus 8 plus 2 is 19, 20, 22, and 24. Right? I had 24 is in the 3 times table as well. So the other number is going to be 987. All right, I like that question. Maybe you learned something about your 3 times table or your divisibility tests. Obviously, it's a calculator paper. You could have just typed each of those 8 numbers into your calculator as well and divide them by 3. There you go. Question 8, back to a good old multiple choice question. Circle the largest number. All right, so we've got 3.27, and then the 7 has a recurring on it, so that's like 3.2777. This is just 3.27. I'm going to add some zeros on there. 3.277, might as well put some zeros, and 3.20777. It's just those 7s that continue on forever. So now if we just look at these decimal places here, like 27,777, just 27,000, 27,700, and 20,777. All right, this last one is definitely not the biggest because it has a 0 afterwards, so not that. If we look, we've got 7, 7, and 7. Those ones are all the same. If we look to the third digit, 7, 0, and 7, so not this one. And then now if we look to the next digit, 7 and 0. It's definitely that first one. You could also probably just guess that one, or you don't need to do quite as much working out as I just did. But nonetheless, there we go. All right, and question 9, good old trigonometry. They're even so kind as to tell you that you're definitely going to have to use trigonometry in this, which is very nice of them. So use trigonometry to work out the size of angle y. All right, first thing we need to do is label this triangle. So we're interested in this angle right here. So we're going to walk directly across, and this side is the opposite side. This side up here that doesn't have a number is the hypotenuse. So the side that's left over is the adjacent. We don't care anything about the hypotenuse, so we can get rid of that. And then we've got to ask ourselves, is it so, is it ka, or is it toa? We only have an O and an A, so it's going to have to be toa. Okay, and then sometimes I like to draw this triangle to help myself remember what to do. The tan of angle theta is the opposite over the adjacent. They want me to find the angle, so if I cover up the tan theta, I have opposite over adjacent, and if we're looking for an angle, we have to use that tan inverse button. So tan minus 1, and then the opposite side divided by the adjacent side. Go over to your calculator, grab that. Tan inverse of 15 over 33, and I get 24.4. There we go. That's done. A nice 3 marks for us. Question 10. Bag A has 2 black counters and 3 white counters, and then bag B has 3 orange counters and 4 green counters. A counter is chosen at random from each bag. Complete the tree diagram. Okay, so both of the branches of the tree are going to have to add up to 1. That you can even check a bunch of stuff in the question. It depends on how you want to do this. So bag A has 2 black counters and 3 white ones. So the probability that you choose a white counter is going to be 3 out of 5, which you could have also got from doing 5 take away 2. There's 5 counters altogether. There's 2 that are black. Also, they told us in the question there's 3 that are white. Your choice how you want to work that one out. In bag B, there's 3 orange and 4 green, which makes 7 in total. If there's 3 orange ones, like they said in the question, there's 4 green, so 4 out of 7. And because the entire second branch is about bag B, we don't have to change the probabilities because they first take one from bag A and then take one from bag B. So the probabilities aren't going to change at all for bag B. Now, I would highly recommend before I even finish reading the question and reading any other part of this, I'm going to write out all my different possibilities. So if I travel down this branch and then this one, that is pulling out a black counter and then an orange counter. Now, you don't have to do this, but I would so recommend it. It's very, very useful. You don't have to highlight the branches as you go, but definitely write out the outcomes at the end. The next one down is going to be black and then green. After that, we're going to have chosen a white counter and then an orange one, and then lastly, a white counter and a green one. So now we can see all of our different 4 possibilities. And remember, we find all of those probabilities by multiplying the probabilities. So to get a black counter and then an orange one would be 2/5 times 3/7. Now we don't have to go and work all of these out, but it's just a reminder as to how we're going to find these. All right, part B, it wants us to figure out what is the probability of choosing a black counter and an orange one. Well, great, I actually accidentally just did that. I hadn't actually read the rest of the question. So we had to do black and then orange. So if we follow down those 2 routes, we're going to end up right here, and that is how we calculate our probability. If you also remember to calculate all the probabilities at the side of everything, you'll get a mark even if you mess up the next part. So 2/5 times by 3/7 is 6/35. And that's all they're looking for on that question. A very nice 4 marks. It's here. I know you're all excited about it. Well, I'm pretty excited about it anyways. Question 11, solve the simultaneous equations. And how nice are these simultaneous equations? So we're either looking to add them together or subtract them. Now we're only going to subtract them if they're exactly the same sign and symbol and everything. So we've got 7x plus 2y is equal to 36 and 3x plus 2y is equal to 16. Now I see a 2y and another 2y. Those are exactly the same, so I'm going to go ahead and subtract these equations to get rid of the 2 y's. If the signs were alternate signs, like if it was a positive 2y and a negative 2y, then I would add them together because they would be alternate signs. But I like to say same signs, subtract. So 2y and 2y are exactly the same, so let's go ahead and subtract these 2 equations. 7x take away 3x is 4x. And 2y take away 2y is 0. Perfect, that's exactly what we wanted. 36 take away 16 is going to give us to 20. And now we have 4x is equal to 20. We can divide both sides by 4, leaving us very nicely with x is equal to 5. And if that's as far as we got, we're still getting 2 marks out of 3. If we need to go ahead and get our third mark, we can substitute the x equals 5 back into either equation. I think that the 3x plus 2y is a little bit nicer, smaller numbers we have to deal with, so I'm going to write that down. We just found out that x was 5, so that's going to be 3 times by 5 plus 2y is equal to 16. So that's 15 plus 2y is equal to 16, and that is an equation that you get asked to solve all the time. So you're going to take 15 away from both sides. We're left with 2y is equal to 1, and then make sure you do this in the right order. You're going to divide both sides by 2 to give us y is equal to 1/2 or 0.5. So x is 5 and y is 1/2. There we go. Beautiful question as question 11. No negatives, nothing crazy, all really nice numbers. All right, question 12, we've got a sneaky little angles question here. So lines A, B, C, D, and E, they intersect as shown in this diagram. And then they say lines A and B are parallel, right? When I'm thinking about parallel lines and I'm thinking about angles, I'm thinking about corresponding angles, alternate angles, and co-interior angles. Those are the things that I am thinking of. They also say work out the size of angle X. Okay, on questions like this, it is absolutely totally fine for you to do most of your working out on the actual diagram. So before I start anything, I'm thinking about parallel lines. Do I notice anything that is like making a letter F or Z? And I do. I see that this angle right here, I've got these two bits here that are parallel to each other, and this nice straight line right here. If this is 110 degrees up here, so is this angle in here. So 110 minus the 52 degrees that we already know, 110 minus 52, we've got 58 degrees left over. So now I've got this angle right here is 58 degrees. Now I'm thinking nextly, I can see this is making like an X shape, and I'm thinking right now vertically opposite angles. So I'm thinking this angle right here and this angle right here are going to be the same. We've got 58 degrees. Now, they didn't actually ask me to give any of the reasons, so I don't have to worry about that per se. Next thing I can see that this is a straight line right here. So I know that angles on a straight line add up to 180 degrees. So 180 minus 49 is going to give me 131 degrees. And now that I've got that, I see another one. All right, I'm thinking co-interior angles now. I've got this straight line and this straight line because they're parallel. And then I have this lovely line here. And it doesn't really look like a C, but these two red angles here are co-interior to each other, and they're going to add up to give me 180 degrees. So this red angle in here is 49, and now that I'm doing this, I'm actually seeing a third way that we can do this as well. But it's all up to you how you want to answer this. Now I can see I've got this triangle here, and I am thinking angles in a triangle. So 58 plus 49 is 107, and angles in a triangle add to 180. So 180 minus 107 is 73 degrees. So there we go. X is 73 degrees. This is by no means the only way you can do this question. I'm sure that I can see at least another 3 ways to do this. Just throwing it out there. I'm thinking that if this whole angle here is 110, then this angle here has to be 70 degrees. Oh, does that help me? No, I feel like I had a better idea. Never mind, ignore that idea. Maybe it's not so good. All right, anyways, answer's done. 73. Moving on. All right, question 13. We've got some averages. To be honest, in general, you guys don't really seem to like averages from a table or anything from a group table, to be honest. This question actually on first inspection doesn't have any averages in this part of the question anyways. I just got a little bit excited when I saw that table there. Anyways, here's some information about the ages of 101 people at a concert. So you have 8 people that are somewhere between 10 and almost 15 years old. 24 people between 15 and almost 25 years old, 30 people between 25 and almost 40, and 39 people between 40 and almost 70. So the inequality signs are really important here. So this means that the people in this group are from 10 years old. So 10, 11, 12, 13, 14, and it's anybody up to, but not actually including 15 years old. So that would be like 14 years and 11 months, or 11 months and a bunch of days, but people who are not quite 15 yet. So the youngest person, write down the age of the youngest possible person at the concert. The youngest person in this group would be 10 years old, because 10 is the smallest number we can possibly have here. Part B, one person is chosen at random. Work out the probability that the person is at least 25 years old. Well, these people are 25 years old and older, and so are these people right here. So altogether, there are 69 people there. So that is 69 out of 101. And that's all we need to do. No need to simplify that further, no need to write it as a decimal. Giving it as a fraction is absolutely fine. So work out the probability that a person is at least 25 years old. There you go. All right, and part C, I thought this was going to be a mean from a frequency table. It's not. It's a histogram. So the exact same table has been repeated. They would like us to draw a histogram to represent their results. So histograms are just there's so many things we can be thinking about with histograms. So with the main things that we need the class width for each of these. So when we draw a histogram, I always think about just drawing a rectangle, and like my first rectangle is going to go from 10 to 15, and it's going to have an area of 8, because in histograms the frequency represents the area, or the area represents the frequency, as opposed to the height. So I always think about finding my frequency density as thinking about finding out what is the height of my rectangle. So in this case, if I had a rectangle with an area of an 8 and a width across the bottom of 5, well, 8 divided by 5 is going to give me 1.6. So it's going to give me a height of 1.6, or a frequency density of 1.6. So I'm going to go ahead and calculate all my widths first. So I have 5 here, and then 10, and then 15, and then 30. And over here, I'm going to calculate all of my frequency densities, or my heights of my rectangles. And I'm going to do those by taking my area, or my frequency, and dividing them by my width. So 8 divided by 5 is 1.6. 24 divided by 10 is 2.4. 30 divided by 15 is 2. And 39 divided by 30, I think it's 1.3, but I'm a bit panicky there. Yeah, 1.3. Okay, and then from those are my heights that are going to go up the side, or as you can see over here, the frequency densities. Now you're going to use a ruler to do this. I don't have that option on this app, so we're going to try our best. So our first rectangle is going to go from 10 all the way up to 15, and it's going to have a height of 1.6. The scale. Okay, so this scale looks like we have 10 tiny little squares, so 10 squares, and they are representing 1 altogether. So that must mean that one tiny little square represents 0.1. I did that by dividing both sides by 10. So we need to go to 1.6. So literally one square after the 1.5. And there is our first rectangle with fairly straight lines. All right, the next one goes from 15 all the way up to 25. Let's change colors so you can see the next rectangle. So from 15 all the way up to 25, it's going to have a height of 2.4. So just below this line here, and then we've got our next one, which goes up to a height of 2, which is a much easier number to go to. 25 all the way up to 40. I have a height of 2. Obviously, you're going to be using a ruler, and it's going to look much prettier. And then our last one goes up to 1.3. So from 40 all the way up to 70, we go to 1.3. So there's 1.1, 2, 3. And there you go. There's our histogram. That is what we're looking for. We're definitely looking for a ruler. No, you don't have to use different colors. And no, you don't have to shade it in. But there we go. 3 marks. Question 14. I'm sorry if this is really squished in when you go to watch this. Obviously, you have 2 pages to do this on. I just wanted to try to get as much information on 1 page as I could. So we've got this trophy of this footballer, and it says the stand is made by removing a small pyramid from a large pyramid. The large pyramid has a square base with an edge of 8 centimeters and a perpendicular height of 16 centimeters. All right, whenever I think of a square, I think back to primary school, and I think, what do I know about a square? It has all 4 sides that are the same. The smaller pyramid, which is the part at the top that's been taken away, has a square base as well. It has edges of 5 centimeters and a perpendicular height of 10 centimeters. They say the volume of a pyramid is given by 1/3 times the area of the base times by the perpendicular height. Well, remember, the base that we have is a square. And then you should hopefully be thinking, what do you know about the area of a square? They want us to show that the volume of the stand is 258 centimeters cubed. So what we're going to have to do is we're going to have to find the volume of the large pyramid, and then we're going to have to subtract off the volume of the small pyramid, and then that should hopefully give us we should hopefully be left with the area or the volume of the stand when we're finished. All right, so the large one is going to be let's write L for large, is 1/3 times by the area of the base, but they told us that the area of the base is a square, so that's going to be 8 times by 8, or 8 squared, times by the perpendicular height, which is 16. We put that into our calculator and we get 1024 divided by 3. Now, I would highly recommend to leave the fraction here and try not to put any decimals, just so you don't end up rounding wrongly on these questions. The small one is going to be 1/3 times by the area of the base, but again, it's a square base, so 5 squared, times by 10. 25 times 10 divided by 3, we get 250 divided by 3. So now we have the large volume and the small one, so we want to take them away. 1024 divided by 3 minus 250 divided by 3 equals 1024 minus 250, 774 divided by 3 gives us, amazing, 258, which is exactly what we wanted, centimeters cubed. Very happy. Yay! All right, part B. The trophy is made from metal of a density. Oh, density. Are you thinking density is, we should draw a better triangle. Let's try that again. As soon as I read the word density, I'm automatically thinking density equals mass divided by volume. The trophy is made from a metal of density 7.5 grams per centimeter cubed. Other random things I'm thinking when I'm seeing this, centimeters cubed. The total mass of the whole trophy, not just the stand, the whole mass of the entire trophy is 2,340 grams. Oh, this is good. We're in units here, same units here. Work out the volume of the player. Okay, so what we want to do is we want to use our density, mass, and volume. From what they gave us in the question, they told us that the trophy is made from metal, which gives us a density, and then they also told us the total mass of the trophy, which is the mass over here. We can use those two things to find the volume of the trophy, and we can subtract off the volume of the stand and just find the volume of the player. So let's go ahead and do this whole thing. So we're looking for the volume of the trophy. And we're going to do that by doing our mass divided by the density. So 2,340 divided by 7.5. 2,340 divided by 7.5 gives us 312. So the volume of the entire trophy is 312 centimeters cubed, but we know that the stand is 258, so just the player is going to be 312, take away 258 for a grand total of 54. There we go. Done. Very nice question. Possibly we didn't need that much working out for just those 2 marks there. But there we go. Question 14 is done. Column vectors. They're not actually asking us to add them. They kind of are a little bit, but also on a diagram. There's so many things happening here. We got question 15. So A is the vector m and 3, and B is the vector -4p. So we don't know how much m is, we don't know how much A is going right or left, and we don't know how much p is, we don't know how much B is going up and down. But they tell us this diagram here shows us the vector of 2 lots of A plus B. Well, I'm just thinking out loud here, so 2 lots of A plus B, so 2A is going to be 2 lots of M and 3, which is going to be 2M and 6. So if I wanted to work out 2A plus B, that would be 2M and 6 plus -4p. So that looks like 2m take away 4 and 6 add p. And what this is telling me as 2a plus b is this is telling me how much is going in this direction, right and left, and this is telling me how much is going up and down. So let's go and look at the diagram. Now the diagram shows us that we start down here and we follow the arrow and we move up this way. So we can go ahead and count how many squares this is. 1, 2, 3, 4, 5, 6, 7, 8. So this whole vector is going to look like 8 to the right, so positive 8, and then 1, 2, 3, 4, 5, 5 upwards. So the vector 2a plus b must be 8, 5, but we also figured out that the 2a plus b, based off of like our algebra, if you will, has to be 2m minus 4. So then we can make like a little equation. So this 8 right here has to be the same as the 2m minus 4. So 2m minus 4 equals 8. And then also this 5 has to be the same as 6 plus p. So you can say 6 plus p is equal to 5. And now these just become two equations that you know how to solve. So first we're going to add 4 to both sides. And we get 2m is equal to 12. And then we can divide both sides by 2. So we get m is equal to 6. And then on the other one, we've got 6 plus p is 5. So we can subtract 6 from both sides. So p is equal to negative 1. And there's our answers. M is 6 and p is minus 1. I like that question. That's quite neat. Don't know how you feel about that. There might have been another way to get there, but 6 and minus 1 is what we're looking for.
All right, question 16. The diagram shows a circle touching a square at A, B, C, and D. Give reasons why y is 45 degrees. So this is definitely a circle theorem question. It is only 3 marks, and normally they ask us to find an angle, and this one's just telling us we need to use a bunch of circle theorems to tell them why. What I would be looking at is in this triangle down here, you've got those two lines there are actually tangents, and because this is a square, we know that this is 90 degrees, but because those two lines dr and rc are tangents, then we know that they are the same size, so this is going to make an isosceles triangle. And if that's an isosceles triangle, then we have this angle and this angle here are both 45 degrees. So we need to give some reasons. So triangle RDC is isosceles, and the reason why it's an isosceles triangle is because RD is equal to RC because they are tangents, and tangents to a circle are always the same length if they meet at a point. And then where are we going from there? And then from there we can say that well, we've drawn the 45 degrees on the triangle, so we should be good from there. And then we can have that angle y is equal to 45 degrees by the alternate angle theorem. And that was mostly what they were looking for in that question. So it's the idea that you had those tangents and then therefore you had an isosceles triangle.
All right, here's a little bit more of a complicated question for question 17. They're just asking us about the turning point, which is the maximum or minimum point on the quadratic. So we're interested in this point down here. Here's a sketch of y is equal to x squared plus bx plus c. So we don't actually know much about the quadratic. The curve intersects the x-axis at 5, 0. So we can see right over here is positive 5, and at point P. We have no idea what this value is. We just know it's a P, that's like the letter P, and that's it. So write an expression for the x-coordinate of the turning point. Well, the x-coordinate is always smack dab in the middle of your two solutions or your roots of your equation. So this x value is going to be exactly halfway between 5 and negative p. So we're basically looking for like a mean of the two things, if you will. So we're going to do 5 plus negative p divided by 2, which you can make a lot nicer by saying 5 minus p divided by 2. And that's all they're looking for in that question. For question 18, we've got some very, very nice algebra here. Simplified fully, 3, and then in brackets, x plus 2 to the power 5. all divided by x plus 2 to the power of 3. Give your answer in the form ax squared plus bx plus c, where a, b, and c are integers. This is, I think it's quite a nice question. So you can simplify this further, or maybe think about it in a different way, as like, what if you had 3x to the power of 5 divided by x cubed? Well, then you'd probably deal with these two things by themselves, and you would have 5 take away 3, which would just give us 3x squared. Well, we actually have the same thing happening in this fraction over here. It's just, instead of having an x, we have an x plus 2. So we can subtract these powers right here, because the x plus 2 are the same bases. So 5 take away 3 is going to give us 2, and we'll be left with 3 bracket x plus 2 all squared, which really just becomes a nice expanding brackets question. So this is going to be 3 times by x plus 2 times x plus 2. So you can go ahead and expand that, and you get x times x is x squared, x times by 2 is 2x, 2 times by x is 2x, and 2 times 2 is 4. And then simplifying that down, 3 times by x squared plus 4x plus 4, and expanding that 3 across, 3x squared plus 12x plus 12. Done. We've got all integers there. That is all we're looking for. 3x squared plus 12x plus 12. How lovely is that? Everything's positive, nothing crazy happening in that question. Lovely. Question 19. A, B, C, D, and A, E, F, G are identical squares. C to D is equal to E to F, which is equal to 10 centimeters. If these are squares and one side is 10 centimeters, then all the sides have to be 10 centimeters. And angle B to A to G is 45 degrees. Prove that triangles AGD and ABE are congruent. So when we see congruent, we should be thinking about angle, side, 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 or right angle, hypotenuse, and side. So let's look at what we've got here. So let's look at the two triangles we're trying to prove. A to G to D, which is this triangle here. And then we also have A to B to E. So A to B to E, which is this triangle here. Okay, so we need to prove these two things are congruent. Well, both of these have a right angle right here in them, because both of these are part of that triangle and the 45 degrees. So if we do these in two separate colors, we can see that this triangle right here, and then we got this whole angle in there, which is 135 degrees. And then same thing with the blue over here, we got that whole angle there is the 90 and the 45, which is 135. But they told us in the start of the question that the two shapes are identical squares. So if one side is 10, then this side over here is also 10. And this blue side, if we're sticking with blue at the moment, is also 10. And if we go back to the red, this is 10, and so is this. And looking at that, I can now see, let's try in black, I guess. We've got a side and a side, 10 and 10, and then an angle in between them. So these two look like they're congruent by side, angle, side, because they both have a 10 centimeters, 135 degrees in the middle, and then another 10 centimeters. So if we are looking at how we're going to write this nicely, we have A to D is equal to 10 centimeters, and also equal to A to G, so that is in the first triangle, but we also have A to E equals 10 centimeters, which is equal to A to B. So those are the two sides, and then you can say angle D to A to G, G is equal to angle E to A to B, which is equal to 135 degrees. So these two triangles are congruent by side, angle, side. And that is all the information you're looking for on this question. So for question 20, when I was putting this together, I saw a similar question to this in another paper, and I just thought it was a really neat way for them to ask about solving a quadratic. It's just a very different way. It's not quite so in your face as just like solve this quadratic or factorize for part A and then part B solve. I thought it like lent itself to being a little bit trickier, but still quite nice. So I just want us to solve this equation. It looks pretty achievable, if I'm going to be honest, and I think you can definitely start it even if you're not sure where to go from here. So first thing we're going to do is on the left-hand side, we're going to multiply that x across those brackets. So it's going to go see that other x to become x squared, and it's going to see the negative 10 to become negative 10x. We still have that plus 9, and then on the other side of the equal sign, we have the x minus 1. Now what I'm going to do is I'm going to subtract off this x over here. So I'm going to subtract off that x over there as well. So I have x squared minus 11x plus 9 is equal to negative 1. And then I'm going to add 1 to both sides. So now I have x squared minus 11x plus 10 is equal to 0. And then from there, I've got a nice quadratic. I'm thinking, can I factorize this? So I'm looking for two numbers that multiply to equal 10. That's the number at the end. Multiply to give us 10. And also add together to give us negative 11. So if they multiply together to give us a positive number, they're either both positive or both negative. And if they add together to give us a negative, in this case, they're both going to have to be negative. So I'm thinking of x minus 10 and x minus 1. 10 times 1 is going to, or negative 10 times negative 1 gives us positive 10. And when you add them together, we get negative 11. We need to keep that equals 0 there, otherwise it's not going to be an equation that we can solve. And then from here, we have two brackets that are being multiplied together. So either the first answer is 0 or the second answer is 0. And when we solve both of these, we end up with x is equal to 10 and x is equal to 1. And there's our answers. X is equal to 1 and, or, comma, whichever word you would like to put in there, x is equal to 10. So realistically, this is just a solve a quadratic, a quite nice quadratic, but it's a little bit sneaky in the beginning. I thought it was really cool. I know that's lame to say. I just thought it was a neat question. Hadn't seen something like that before. So there you go. 21, we've got a nice real life graph. A container is filled with water in 5 seconds. Right, you can see it starts here at 0 and goes up to 5 seconds. The graph shows the depth of the water, d centimeters, at time t seconds. Part A, the water flows into the container at a constant rate. Which diagram represents the container? Circle the correct letter. So that is going to be C. And the reason why it's going to be C is that you can see if you're looking at the graph, if you look at these look like nice straight lines, nice smooth curves, you can see what's happening. If you look at that blue line, if you look at the gradient of it, it's slowly getting flatter, if you will. So the gradient is decreasing each and every time. And towards the top, what's happening, that gradient is really getting nice and flat and nice and shallow. So the water is taking a lot longer to fill up, i.e. the top of the whatever it's filling has to be a lot wider, which is exactly what's happening here. For C, you got something really small at the bottom, and then it's quite big at the top, so it's going to take a lot longer to fill at the top, and that's why it's C. All right, part B. Use the graph to estimate the rate at which the depth of the water is increasing at exactly 3 seconds. You must show your working. So at 3 seconds, so that's that point right there, you're going to use your ruler to draw a tangent. And a tangent is a line that just crosses the graph at exactly 1 point. So you want it to try to, we'll see how I do this with a ruler. I'm actually going to put a ruler on top of this. I don't know if it's going to work or not. So I'm placing my ruler on my graph, and I want it to try to, my line to only touch my graph at exactly that blue dot that I've just put. All right, so there we go. There's my tangent that I've tried my best to draw at exactly, that's a bit dodgy. We'll go with it. It should be fine. Okay, so there, I'm hoping it's just crossing the graph at that 1 point. Obviously, it doesn't have to be perfect, and you're marking the intention, but if you don't draw a tangent, you can't get any marks from this at all. And then from there, we're just going to go ahead and estimate any 2 points on this graph. We're going to try to find the gradient. So this looks like a fairly decent point to check right there, and that looks like the point 4 across and maybe 25.5 up. And then let's choose any other point. This one looks pretty decent. Why not? It's really far away, but we'll go for it. 0.5 across, but it's a very nice 10 up. And now I'm just going to find the gradient between those 2 points. So 25.2 minus 10 divided by 4 minus 0.5. Let me just grab my calculator real quick. 1 second. All right, and from there I get 31 over 7, which as a decimal is 4.4. Now, they are going to take any answer at all that I give that is in the region of 3.6 to 4.4. And honestly, the line that I've drawn there is a little bit steep. It should be a little bit flatter. Mine is more like a tangent around 2.7, but you know what? I did my best with my ruler on my iPad, so we'll see how that goes. But you will get any answer that's correct between 3.6 and 4.4. So I'm going to leave my answer as 4.4. Again, you must draw that tangent in order to get a mark for this. Oh, we got some more algebra for question 22. It's a show that question. So I secretly love show that questions because basically they're like, here's the answer. We really hope you get the same thing. So I would actually cover up all of this part over here and it would say, add these two fractions together. So that's what this question is asking me to do. Even though it says show that, I can see there's two fractions, 4 divided by x plus 2 divided by x minus 1, and they want me to add them together, and basically they're saying, let's hope that you get this lovely fraction over here. So let's go ahead and add these fractions together. Just like normal fractions, we need to make a common denominator. Typically in algebraic fractions, the easiest way to do this is to multiply the two denominators together. So to the first fraction, I'm going to multiply the top by x minus 1 and the bottom also by x minus 1. And to my second fraction, I'm going to multiply it by x and also by x. So this will look like 4 times by x minus 1 all over x times x minus 1, and then plus 2 times by x divided by x times x minus 1. Remember, when you multiply, 2 times by 3 is the same as 3 times by 2, so it doesn't matter which order you put your x and your x minus 1 in terms of like if the x is in front of the bracket or at the back of the bracket. All right, expanding out the first bit, I have 4x minus 4, and that's going to be over this fraction or over this denominator, plus 2x all over x times x minus 1. All right, now that both of those fractions have the same denominator, I can make them into one giant fraction. So x times by x minus 1, and both of the numerators can go on there. 4x minus 4 plus 2x. So I can go ahead and add those together. 4x plus 2x gives me 6x, 6x minus 4, and x over or x times x minus 1. Yay, that's exactly what they wanted me to get. Okay, show that it was done. I didn't even worry about making sure I was going to get 6x minus 4 divided by x times x minus 1. I just added them together and I hoped for the best. And that's what I would do in that question. So pretend that they didn't give you the answer and just hope that you get the same thing. Question 23. On first inspection, this one looks kind of terrifying, but the more I looked at it, it's actually not as crazy as it seems. A chocolate box in the shape of a prism is being designed. All lengths are in centimeters, and the cross section is a regular hexagon with side x. The length is 5x. Sorry, just looking at the picture again. So we've got, it kind of looks like a Smarties tub. That's all I can think about at the moment. An expression for the area of the cross section. So this is the area. So that's this part here of the cross section of this lovely hexagon. That right there is 3 root 3 divided by 2 times by x squared. So that's obviously that side of it. But remember, there's that exact same shape on the other side as well. So there's 2 of those. The total surface area of the box must be less than 650 centimeters squared. Work out the largest possible integer value of x. You must show you're working. Okay, so surface area just wants us to find the area of all of the surfaces. So we've got 2 times by 3 root 2, or 3 root 3 over 2 times by x squared. That is for the front face and the back face. And then also we have the 6 rectangles that are around this whole shape. So like this shape right here, there are 6 of those around the whole thing. And that is going to be 5 times by x, which is going to give us 5x squared. But don't forget there are 6 of those, so we got to times all of that by 6. So that is the blue faces and then the 6 rectangles, and they want all of this to be less than 650. So let's do some maths and clean this up. Those 2's are going to cancel each other out, and now we have 3 root 3 x squared. 5 times 6 is going to give us 30. So plus 30x squared, and that has to give us a number that is less than 650. If we go ahead and try to add this together, or if you want to, you can factorize out an x squared. It's depending on how you're thinking about this, it's fine. So we're looking at 3 root 3 plus 30. We want to find out when is that going to be less than 650. So I can divide both sides by my bracket. So x squared is going to be less than 650 divided by 3 root 3 plus 30. I'm going to go ahead and grab my calculator for this one. 650 divided by 3 root 3 plus 30. Close that bracket. All right, so I want to find out when is x squared going to be less than 18.4679 and a bunch more decimals. And so the square root of that. So x has to be less than 4.297 and a bunch more decimals. If x has to be less than that and it has to be an integer, then x is going to be equal to 4. There we go. Answer 4. Oh, that's quite a nice question, actually, in the grand scheme of things. But there we go. That's all we're looking for in that one. Looks way scarier than it really is. Sorry I didn't write on the lines. I definitely thought it was going to take a lot longer than it did. There we go. All right, for question 24, we're looking to work out the area of this triangle BCD. Now, don't forget, in your exams, you're going to get given those formula sheets, so you need to make sure that you know where to look up these formulas. So for this one, I can already see, because they've given me the angles, I need to use my area of a triangle from trigonometry. So I need to use that the area of a triangle is 1/2 AB sine C. So you need to be looking for that one on the formula sheet. So we need two sides and the angle that is between those two sides in order to calculate the area. So if we look at this triangle, we have two angles and then one side that's between them, which is not really very helpful for us finding the area. But because it's a triangle, we can always find this third angle here. So 180 take away 39, take away 43, we get 98. So this angle in here is 98. And the reason why I'm thinking that that's useful is because now I have a nice little pair of a side and a matching angle, which is giving me some sine rule vibes, if I'm honest. Now for the sine rule, you just need to have two pairs of matching sides and angles. Now for the area of the triangle, which I want to find, I'm either going to have to find this side, which I'm going to call A, or I'm going to find this side, which I'm going to call B. It doesn't actually make a difference which side you decide to find. It just is like, do you like 39 or do you like 43 better? It's honestly a personal choice on that one. It doesn't really matter. I'm going to go with 39, and we'll call this little side B over here. So we have a matching pair of sides and angles. So I want to find little side B, so I'm going to put that on the top. So B divided by sine 39. Oh, remember, if I forgot this, I could also check this out on the formula sheet. B divided by sine B equals C divided by sine C. Now, I think that the one on the formula sheet has the angle at the top, but it doesn't really make a difference as long as you are consistent with either the side at the top or the angle at the top. So I want to find the missing side, so I'm going to put the side at the top. So B divided by sine 39 is equal to 9 centimeters divided by the sine of 98. Then I'm going to bring that sine of 39 up and multiply. So B is going to be 9 over sine 98 times by sine 39. Do be careful with your brackets when you're doing this kind of a question. That can really make a massive difference in this sort of calculation. All right, and from there, I've ended up with side B is 5.7. I'm going to go 5.72, I'm going to call it. So now I've got that side B is 5.72, and from there, I can now see that I have this side and also this side and the angle in between them, so I can go ahead and find the area. So the area of the triangle is going to be 1/2 times by 9 times by 5.72 times by the sine of 43. 0.5 times 9 times 5.72 times the sine of 43 degrees. I got 17.55. I'm going to call it 17.6, and this is centimeters squared. The units are obviously on the line. I don't know why I did that. 17.6. There you go. That's how I'd answer that question. 25. All right, I'm a little bit maybe too excited about this question, and I apologize for that. Maybe you have a better way to approach this question than I do, but here is how I would do this question. It's a little bit of like I kind of think about it like a Sudoku, of like it's a little bit of a puzzle as to the things you're trying to look for. So B is 2/3 of C, and 5A is equal to 4C. They want us to work out the ratio of A to B to C. So initially, I'm seeing that the first line is telling me the relationship between B and C, and the second line is telling me the relationship between A and C. So I'm going to have to get C in common and then work from there. So I'm going to start with a nice little equation. B is equal to 2/3 of C. And I'm going to deal right now with just that first line. What I want to do is I want to get rid of this 3, and I'm going to bring it up and put it beside the B. So I'm going to have 3B is equal to 2C. And that's because the opposite of divided by 3 is just times by 3. And then from there, I'm going to write these two things as fractions. So this part's a little bit weird, I guess. I'm going to bring the C down here, and I'm going to divide it underneath the B. And I'm going to bring the 3, oh, this feels really silly. It's okay, down here and divide it underneath the 2. You're probably like, why did you just get rid of that? It's just how I like to do things. So I'm going to have B divided by C equals 2/3. And the reason I want to do that is because I know that I can write my fractions as ratios. So I can say B to C is equal to 2 to 3. Now I'm going to do the exact same thing with my 5A to 4C. So 5A to 4C, I'm going to turn those into equal signs like they're supposed to be. I'm going to bring the 4 down here underneath the 5, and I'm going to bring the A down here underneath the C. So 5/4 equals C over A. So that means 5 to 4 is equal to C to A. And now I can make some comparisons. So I know that C in this ratio is 3 and C in this ratio is 5. But what do 3 and 5 have in common? They both have 15 in common. So I can make two new ratios that are both with a 15. Here I'm going to times by 3. So 15 to 12 is C to A. And over here I'm going to times by 5. So B to C is 10 to 15. So altogether, A to B to C, which I can now compare because they're all in the equivalent of C. A is 12, B is 10, and C is 15. There we go, done. 12, 10, 15. I'm sure there are other approaches you can also take. That is just the way that I would do this because I like to think about fractions turning into ratios. Question 26 involves a lot of, not a lot of, but a little bit of thinking about what are the possibilities of what could happen versus actually trying to figure everything out. So Ray has 9 cards and they're numbered 1 to 9, as you can see there. Ray takes at random 3 of these cards. He works out the sum of the numbers on the 3 cards. So he's going to add up the three cards, and then he records the results. Work out the probability that the result is an even number. Well, before we get to this question, because it's so close to the end of the paper, when you're thinking about getting an even number, you got to think about how can you get an even number? Well, you can get an even number by adding up an even card plus another even card plus another even card. That's definitely going to give us an even total. Like just think 2 plus 2 plus 2, going to give us 6, which is an even number. Is there any way that we can use the odd numbers as well? Well, if we add together 2 odd numbers, like just say for instance 3 and 5, that's going to give us 8, which is an even number. So an odd plus another odd number plus an even number is also going to end up equaling an even number. Unfortunately, that's not the only way that one can happen. There's other possibilities for this. We can also choose an odd number and then an even number and then an odd number, and our total would still be an even number altogether. Or we could choose that even card first and then 2 odd cards afterwards. And those are our 4 possibilities that we actually have to work out. So working out the even one is actually really, really nice. We just try to figure out what are all the probabilities of getting even cards. So 2, 4, 6, and 8. There's 4 cards there, so that's going to be 4 out of 9. But if I choose one of those even cards, there's only going to be 3 left. But if I choose any card at all, there's only going to be 8 left. Again, if I choose one of those even cards, there's now only going to be 2 left. And then if we've chosen 2 cards, there's only going to be 7 left. So we can work that out. And then for the next 3 options, how many odd cards are there? 1, 3, 5, 7, and 9. That's going to give us 5. So 5 out of 9 times by, if we've chosen an odd one, there's only 4 left. And again, there's only 8 cards because we've used one of them. And then if the last card is even, we haven't chosen any even cards. So there's 4 ways we can do that out of 7. Now, the next 2 options are actually going to have the same probabilities. They're just going to be arranged a little bit differently. So the odd card is still going to be 5 out of 9, but we haven't chosen any of the even ones. So now it's going to be 4 out of 8. And for the last odd card, it's still going to be 4, oops, that's a times, out of 7. So it's the same thing, exact same numbers, just we're choosing things in a different order. And then lastly, we choose an even card first, which is 4 out of 9. And then we choose our odd card where there's 5 out of 9. No, not out of 9, out of 8. And then we've already chosen one of the odd cards. So instead of there being 5, there's only 4 left out of 7. So all the tops are 4, 4, 5, and all the bottoms are 9, 8, 7. So let's go ahead and multiply these all out. 4 times 3 times 2. I'm just going to multiply all of the tops and all of the bottoms just to keep everything nice and clean. I'm not going to simplify anything until the very end. Now, if I was being sensible, I could have just gone with my even, odd, odd, and I could have just multiplied my answer by 3 instead of working it out 3 times. But, we've done it. We've committed this far. And then to find the probability that the result is even, obviously we're just going to go ahead and add these all together. So 24 out of 504 plus 80 plus another 80 out of 504 plus another 80 out of 504. And working that out, we get 264 out of 504. And if we want to simplify that down, 11 over 21. Okay, you can also give it as a decimal, whichever way you choose. And that is about it. That's all we're looking for in that question. Again, it's about trying to figure out what are the possibilities of how you can rearrange the numbers without actually writing out all the different pairs of numbers. There we go. And lastly, but certainly not least, the graph of x squared is transformed by the vector 0, 2. So that means 0 to the right. Oh, the pen's not really working there. Let's try again. 0 to the right and 2 up. All right, so that's what's happening there. Write down the equation of the graph. Well, the graph has just been moved 2 up, so it is y is equal to x squared. And then because this transformation is happening to the y, it's happening after everything. So we take all of the x squared and then we add on 2 at the end of it. Now, I am not going to lie to you about part B. There is, I feel like, a letter missing from it, and it's my fault because I made the paper, but I'm really sorry, and it was only 1 mark, and hopefully you still understand the question. So here are sketches of 2 different graphs. You've got graph A, which we actually don't care about at all, and then we have this other lightly colored graph. It says the graph of y is equal to x squared minus 1 is reflected in the x-axis to give graph B. So they take this light colored one and they flip it upside down so it looks something like that. They want us to work out the equation of graph. There should be a letter there. I'm sorry, it should say graph B. So they want us to figure out what's happening here. And all that's happening is all of the y values are becoming negative. So you're essentially multiplying the y by -1 or everything else by -1. So I would say y is equal to negative x squared plus 1, because you've literally multiplied all of the values by -1, which takes them from being in the positive y's into being into the negative y's. And there we go. Obviously, if you wanted to write this question as y is equal to 1 minus x squared, totally appropriate as well. Either of those would be acceptable. And that is us done. Hope you enjoyed that. Stay tuned for paper 3. Bye.